Imagine an AI that not only recognizes what's in your photo, but actually thinks about it like a human. That's exactly what QVQ Max makes possible. Hello, dear AI enthusiasts, and welcome to a new video. Today, we're talking about an exciting development in the field of visual AI, QVQ Max, from Alibaba's Qwen team. This new model could fundamentally change the way artificial intelligence processes visual content. It's a visual reasoning model released in March 2025 by Alibaba's Qwen team. It's the evolution of the experimental model QVQ-72B preview, introduced in December of the previous year. Unlike conventional visual AI models that can only recognize and describe images, it combines visual perception with logical thinking. The key difference lies in the reasoning, the process of thinking and drawing conclusions. QVQ Max doesn't just see what's in an image, it can analyze the information, make connections, and draw complex conclusions. It's like the AI is having an inner dialogue with itself about what it sees. Before I dive deeper, let me quickly touch on the current limitations. It requires significant computing power, can still hallucinate when dealing with complex visual content, and raises important questions about data privacy. We'll take a closer look at how these aspects play out throughout the video. In your daily life, you don't just absorb information through text, but also through images, diagrams, and videos. A picture often contains a wealth of information like colors, shapes, spatial relationships, and more. These elements are often more intuitive, but also more complex than text. Take an architectural plan as an example. A pure text description may not be enough to judge whether the plan makes sense. But if you can see the plan and analyze it with technical knowledge, the task becomes much easier. That's exactly where the power of visual reasoning lies. It enables the AI not only to see, but also to understand and think. It's like it doesn't just recognize the ingredients in a recipe image, but also considers whether the combinations will taste good and what alternative ingredients could work, just like an experienced chef. The Qwen team equipped QVQ Max with 3 core capabilities: detailed observation, deep reasoning, and flexible application. With detailed observation, it can precisely analyze images, whether it's a complex diagram or a casual snapshot. It quickly identifies the key elements of an image, recognizes objects, text, and even tiny details that might escape the human eye, much like a detective examining a crime scene. With deep reasoning, it goes beyond just identifying content. It analyzes the information and combines it with background knowledge to draw conclusions. For a geometry problem, for example, it can derive answers based on included diagrams. In a video clip, it can predict what might happen next, like a chess player thinking several moves ahead. A critical issue I noticed during my tests: for very ambiguous images or unusual contexts, the predictions can be inaccurate. Flexible application allows QVQ Max to take on creative tasks as well, such as designing illustrations, generating video scripts, or even creating role-playing scenarios. It can turn a rough sketch into a complete piece or critically analyze a regular photo. What I personally find most impressive about this model is how it blurs the line between human and machine thinking. When I saw the first demos, I was stunned at how human-like the thought processes were. It almost reminded me of moments when I tried to understand complex visual information myself. QVQ Max is based on a mixture of experts model, trained with about 20 trillion tokens. Think of it like a massive neural network made up of specialized expert modules, like a team of professionals, each highly skilled in their own field, working together. The developers used supervised fine-tuning and reinforcement learning with human feedback for post-training. One of the most interesting features of the model is its adjustable thinking time mechanism. That means you can give the model more time to think before it responds. The more time it has, the more accurate the answers get. This is similar to how humans pause and think before giving a complex answer. However, this accuracy comes at a cost. The resource consumption increases significantly with longer thinking times. It offers a wide range of applications across various fields. In the workplace, it can be used for data analysis through visual interpretation of charts and graphs, code development based on diagrams or sketches, and interpreting complex documents and plans. In education, it can help solve difficult math and physics problems with diagrams, explain complex concepts in an intuitive way, and support the understanding of visual scientific data. A practical problem I found: in highly specialized areas of math beyond its training material, the model can sometimes go off track. In everyday life, it can suggest outfit combinations based on wardrobe photos, guide you in cooking new dishes based on recipe images, and analyze environments and spaces for optimization suggestions. I experimented myself and had QVQ Max analyze a photo of my chaotic bookshelf. Not only did it recognize all the book titles, but it also identified thematic connections and even suggested how I could better organize the books. In various tests, it demonstrated impressive capabilities. With multi-image recognition, it can analyze multiple images at once and establish relationships between them. It can, for example, identify similarities and differences between various landscape photos, recognizing themes, moods, and symbolic connections. For OCR in different languages, the model can extract text from images and recognize and translate languages like Arabic, Hebrew, Russian, and Spanish. It can even interpret handwritten text, although the recognition rate drops significantly with very poor handwriting. In geographical and geological analysis, during tests with images from different regions, like the Australian outback, it could not only identify the location, but also explain geological processes, like why the soil is red in certain areas. For video analysis, it can analyze short videos frame by frame and derive information about the content, context, and even the purpose of the video. For PDF and document analysis, the model can extract and process information from PDFs and other documents, though it hits limits with scientific papers containing complex formulas. In mathematical reasoning, QVQ Max showed continuous accuracy improvement on the MathVision benchmark when the maximum thinking time was in. If you want to try it yourself, you can test it through Qwen Chat. Go to chat.qwen.ai. The link will be in the video description. Select Qwen 2.5 Max from the drop-down menu, activate thinking mode, and upload images or documents. A tip from my experience: experiment with different thinking time settings to find the best balance between speed and accuracy. The Qwen team emphasizes that the current version of QVQ Max is only the first iteration and that there is still a lot of room for improvement. In the future, they plan to focus on several key areas: more accurate observations using grounding techniques, a visual agent for multi-step and more complex tasks, and better interaction beyond text-based communication. It's worth noting that this model enters a highly competitive field of visual AI. While companies like OpenAI, Anthropic, and Google are working on similar technologies in the US, the release of QVQ Max shows that Chinese companies like Alibaba are also leading in AI innovation. In fact, this is already the third model Qwen has released in 1 week, alongside Omni and Qwen 2.5 VL. This indicates an accelerated pace in AI development and shows that the gap between the US and China in the AI race is narrowing. Alongside its strengths, there are also critical aspects. Like many advanced AI models, the resource consumption is high and requires significant computing power. Privacy and ethics raise concerns, as the ability to deeply analyze images and videos brings up questions about data protection and ethical use. Despite its advanced capabilities, reliability can still be an issue with complex or ambiguous visual content, leading to errors or hallucinations. Access is currently mainly through Qwen Chat, and it's not available as a fully open model, which could limit research and development by the broader community. In my experience, the greatest potential of QVQ Max lies in its ability to act as a true visual assistant, capable of solving complex problems that were previously only solvable by humans. With its ability to understand visual content and not just see it, it could change the way you interact with AI. What do you think about QVQ Max and the future of visual AI? Let me know in the comments. If you enjoyed this video, leave a like and subscribe to the channel. And if you activate the bell, you'll even get notified when we upload a new video. Hope to see you next time. Until then, stay real.